Hi guys, we're back. It's Mr. Robeson here. This is the last one for 7.3 and the last one for Unit 7 here. So we're going to look at how to make confidence intervals for the mean using data. So if we have actual data values, and we're going to look at how to find the minimum sample size, just like before when we did for proportions. All right, so for this one, we're constructing a confidence interval for the mean, population mean. A manufacturer of high-resolution video terminals must control the tension on the mesh of wires behind the screen. Too much will tear, too little will cause wrinkles. The tension is measured by an electrical device with output readings in millivolts, or MVs. Some variation is inherent in the production process. Here are the tension readings from the random sample of 20 screens from a single day's production. All right, so we have actual data here. Here's the actual screens that were measured. Construct and interpret. So we want to construct it. That's the do part. Interpret. That's the conclude part. And 90% confidence interval for the mean tension of all screens produced on this day. All right, so we'll just start with our state. So we're going to state that our mean is the true mean or the population mean. And generally start using the word true just because it's shorter. But population mean, and this was tension. Let's see, tension on the wires behind the screen. Tension on the wires. I don't even know what we're talking about here, but that's okay. It doesn't matter. The screen. And let's see, what do we know? Well, we know our sample size is 20. We know our confidence level is 90%. And we know we're working with the actual data. So we've got the data values here. All right, so that's all we need to write for now. So we'll move on to plan. So the plan is to do a one sample, because we have one sample. We're finding mean, so that means we're doing t. So a t interval for mu. Notice I never write x bar here. It's always mu, because we're always finding the interval to try and infer what the population mean is. Now we check our three conditions. Do we have a random sample? Well, let's see. Right here, a random sample of 20 screens. Random sample is stated. Next up, our sample size is 20. All right, so central limit theorem, not going to do it for us here. It's less than 30. That doesn't work. All right, we don't know anything about our population being normal at all. So we're going to need to look at a graph. All right, and if we look at a graph, we generally want to sketch a graph. So what we're going to have to do to make the graph is we're going to have to put the data into our calculator and then have our calculator graph it. So let's see. I did go ahead and I put the data into the calculator. So I went to Stat, Edit, and here are all those numbers in L1. All right, but we want a graph. So remember, when we're graphing in Stat, we go to Stat Plot. And let's see, we can do a couple of different graphs if we want to. Let's try first one. Let's just try the box plot with outliers, because that'll tell us if we have outliers. And outliers is one of the things we were looking for. Okay, everything's set. So graph. And I don't have anything on my picture. Well, it looks like I have a parabola from something else. All right, but again, I don't have any box plot. That's because all these numbers are in the 300s. So I'm going to zoom stat, which is number 9. There it is. Hey, look at that box plot. That looks pretty nice. All right, one thing I noticed is that it doesn't have any outliers. So I'm going to sketch this box plot. It doesn't have to be perfect. I'm going to sketch it right here. It looks like the line was a little bit more to that side. But there we go. And I'm going to say no outliers and not strongly skewed. I do want to state both of those things. No outliers, not strongly skewed. So then we've got that it is an approximately normal sampling distribution. All right, so condition 2, check. It's a little more work than normal, but we can do it. All right, now n equals 20. Is that less than 10% of all, I guess, screens made in a day is what we're talking about here. Screens made in a day. So as long as we have 200 or more screens made in a day, we're good there. All right, so now we come here to the do box, and we're going to do a T interval. Actually, I guess it's capital T in the calculator, isn't it? All right, so we go in to our calculator, and we've got stat test. Now I've already put the numbers into a list. So either I can do one variable, I can go to calc and do the one variable stats on them, and I can get this data here. Otherwise I wouldn't have this data. That's where I got this data from. Or I can just go straight into T interval, and instead of picking stats, because I didn't have the stats ahead of time, I didn't have the mean and standard deviation ahead of time, I can go to data, and then it asks me, what list am I using? Well, I'm using L1. Frequency level, always leave that as 1 in this class. And confidence level, let's see, we're working with a 90% confidence interval here. And press enter. And now go ahead and write down everything. All right, so you can write down the sample mean, the standard deviation, the sample size, we already wrote that down, but write down everything here. So 292.41 to 320.39. 292.41 to 320.29. And then we had our X bar was 306.4, and our standard deviation is 36.18, I believe. Check and see. 36.18, yep, 36.14. Oh, it was 39, not 29. All right. There we go. Easy fix. And now we conclude. All right, so we are 90% confident that the interval from, and let's say 292.41, and our units here are MVs, millivolts, MV, to 320.39 MV captures the either population or true mean and mean tension on the wires behind the screen. I'm just recopying what's written here. Mean tension on the wires behind the screen. And there we go. There's our conclusion. All right, so I know this is sometimes tedious having to write out the same thing over and over and over again, but get used to it. These are easy questions to get right on, especially the free response on the AP. There's almost always, actually I will go ahead and say it, there is always an inference question on one of the AP free response. So there's 6 questions there. One of them is always involving inference. So one of them always involves this stuff. And they're not hard to do. All right, so again, here's just a recap on your calculator if you want to see it. So we have the data option, and this is on the older calculators here with the example we just did. And this is back to the booked example, and this is using stats, the mean and the standard deviation. So if we're given the sample mean and sample standard deviation, we're using stats. If you have an actual data list, then you can use data. All right, and we're always using, for mean here, we're using T intervals, which is the number 8-1 under stat and test. All right, the last thing here for this section is, again, finding our minimum sample size. So our margin of error uses T star, which we need the degrees of freedom to get, which we need N to get, and it has this N here. So it has 2 different N's within the same equation. All right, so 2 different things depend on N. All right, that gives us a problem. That means we wouldn't be able to solve for N because we wouldn't be able to get this T star here. So what we do is, well, we kind of fudge it. All right, we cheat a little bit. So instead of using the T star, we use Z star. We go back to Z star because that does not depend on N. And we use whatever standard deviation we could have. So we haven't taken a sample yet so we won't have this sample standard deviation. So if we know it from another study, or we take what we call a pilot group or a pilot study, and we find the standard deviation for the pilot study, which is just S. And we use that instead for this. And then we can solve this just like we did before, all right, which we'll do right here. So admin at your school wants to estimate how much time students spend on homework on average during a typical week. They want to estimate the population mean at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicated that the standard deviation is about 154 minutes. How many students need to be surveyed? All right, so it's asking how many students, so that means n equals what is what we're trying to find. All right, so that's how we know that this is looking at us for our sample size. So in other words, we're going to use z star times the standard deviation over the square root of n is less than or equal to the margin of error. So now we're going to plug in what we know. We want the margin of error to be at most 30 minutes. We've got our sampling standard deviation from that whatever that pilot study was at 154 minutes. 154, not 150. N is what we're trying to find. And we need z star. Well, that comes from 90%. So if you remember, the z star for 90% is 1.645. If you don't remember, you can draw out your curve. You can put the 90% in the middle, which leaves us with 5% on each side. And then we do inverse norm with the 0.05. And you can use just 0 and 1 for mean and standard deviation. And that gives us the 1.645 for our z. Technically, it'd be negative here and positive there. Doesn't make a difference. 1.645. All right, and now we're trying to solve. So let's see. I can just go ahead and multiply these two numbers together. And there's multiple ways you can go about doing this. We broke it. All right. 1.645 times 154. 253.33 over the square root of n is less than or equal to 30. All right, so I'm just going to multiply this up, and then I'm going to divide this 30 down. So I'll get 253.33 over 30 is less than or equal to the square root of n. So then I'm going to have to square both sides to solve for n. So I'm just going to work this out now. So this guy divided by 30 gives me what? 8, and then we want to square that. That gives me 71.3, and just like before, we always round this up. So our n has to be greater than or equal to 72. So we're going to need to take a sample of at least 72 students in order to find a 90% confidence interval with a margin of error of at most 30. All right, so that's how we find our minimum sample size. And again, always round up here. I probably should state it. And it's not really even rounding. It's just bump it up to the next number. Unlike the AP exam, they'd probably have 70 would be an answer, 75, 80, 85. And what we would want to go with here would be the 75 because it's the smallest number that's bigger than our 72 here. All right, so that is how we do our confidence intervals with data and how we find minimum sample sizes. And that is it for 7.3. So get working on that homework.